also called as mean max scaling. And I just wanted to change this to, anybody try with normalizer yesterday? Why didn't you try? Where level encoder? It's already yesterday we done, right? Okay, so just, okay. All right, just one moment, just one moment. Let me do it again. So let me tell you, if I execute entire script at once, yesterday you said that to explain again. Come on, Washim, explain again. Okay, that's no worries. So if I wanted to execute entire script at once, you no need to run one by one. You have to execute this green buttons so that, did you see the kernel is executing, isn't it, guys? Yep. Just one moment. And I think just bear with me. Not this. Let me open your task. Sir, in test only fit is used. It's not like that, Abhishek. I will tell you many more things. Fit and transfer, you can use in numeric, you can use in text, and you can use everywhere. Understand? Just one moment. All right, so here we go. So today's date is 12th. So I think yesterday we didn't do normalizer. So let me try to do with normalizations. Okay, this one, if you notice this part, the first one, we import 3 packages. Everybody understand this one? The second one, we import the data set and we split into independent and dependent variable. And then we impute with simple imputer if it's spider versions 4, isn't it? And the next part, I just impute this numerical techniques with mean strategy, with parameter tuning, does not hyperparameter tuning. Yes, guys. And then I impute encoding techniques using label encoder. All right. So in next sessions, I'll talk about what is one hot encoder and dummy variable trap. Okay. And then why also required, isn't it? Because why? Yes and no. So those are categorical part. So I've been changed to numerical as well. And the second one, train test split. What it do, guys? It split the data set into training phase and testing phase. And for this data, we consider 20% as a testing data, guys, which is test site is 20%, right? And then we implement feature scaling, right? So what exactly happened in the scaling? Let's do this. Xtrain. Did you see, guys, all some of these things, it will transfer to 0 to 1. Yes, this is the scaling. I mean, in every model, each and every model, we're going to work on normalization, scaling, standardizations, but mostly we will use standard scaler. Okay, so 90% scenario we will use standard scaler, guys. All right, I want everyone to please complete. This is the data pre-processing steps, guys. This is called data pre-processing steps, and we completed. Yes, guys. Only transform is used where Abhishek? X test. Why don't you look at this one? We've been used here also, isn't it, Abhishek? Okay, I will share this one. Everybody's understand the data pre-processing steps? If yes, I'll go ahead with the simple linear regressions, model building, and we understand algorithms from today onwards. Clear? Online team? Everybody's clear? Everybody's clear this part. Can we go ahead to the next step? All right. And this is very simple data set we have, isn't it? This is a very simple data set, guys. I wanted to give you a small task today, and let's see. Good morning, Chandraharsh. So data set, data pre-processing. Okay, let me, what exactly it's saying? Data pre-processing for beginners. Little bit in-depth understanding for this data. Let me open up. Just one moment. Okay, so everybody watched Titanic movie, isn't it? Yes or not, guys? Yeah. So in this case, I'll create one data sets. Just one moment. I'll show you. So what is the movie baseline? That means how many male will be survived, how many passengers are survived, and how many of them are not survived, isn't it? So did you see, this is what the data set I have, right? Data pre-processing for beginners, understand? So what you do today, let's copy this and let's copy this, just one moment. Just 1 second, guys, project list. So ML is started now. So this could be your project number 15, and this would be data pre-processing, and project 14 would be your data pre-processing for classwork. Understand? Yes, guys. So now this is the basic understanding. This is the basic practice. We understand how to impute all the technologies. I mean, technique, label encoder, and one not encoder. And now this is for a little bit practice to it, the data pre-processing. Let's do this, guys. Listen to this: machine learning from disaster. Okay, what is the data set name? Data pre-processing for beginner, Titanic machine learning from disaster. Let's go back to the data. If you know how to download the data sets, guys. Yes, very simple. I don't need to explain again. You just click this one, download, click on the test.csv, download, train.csv, download. Okay, when you give interview, they will give you this type of train.csv file and test.csv file. Clear? Now if you look at this, just go back to the columns informations. Just go back to the columns informations. In this column, see, did you see passenger ID, P class, name of the passengers, gender of the passengers, age of the passengers, SIB, SP? What exactly mean by this? Let me explain you. Just one moment. Did you see first NumPy and all those things? Performing data cleansing and analysis means what you're going to do in this data sets. I'm going to explain you. Survived 1 or 0. Classifications or regressions, guys? Classifications. Survived means 1, died means 0. One moment, I think I have data set. Let me show you. Yeah, I have the data, please. Okay, did you see? Passenger ID, survived. Can I say this is dependent variable? Yes or not? Can I say this is dependent variable? Passenger's name, gender, age. No need to explain this one. Let me explain what is SIBSP. SIBSP means, where is that? Passengers class, guys. First class, second class, third class. I hope you understand. When you travel, you have like sleeper, first tier, second tier. So this is called passengers class. And gender, you know this SIBSP means number of siblings, spouse aboard perk, means whether the passengers come along with the siblings or spouse. I hope you understand. So SIBSP. Understand, some children travels with the nanny, therefore the perk equal to 0 for them. Team, are you understanding? Yes, what exactly mean by this data set explanations? SIBSB means some children's, I mean, one means they are went to the ship along with the, some of their siblings, spouses, and something like that. Yes, ticket numbers. This is ticket number. I hope you know this. What is meant by perk? So the perk means 0. Okay. So if they're traveling with their family members, then it could be 1 or else it could be 0. Ticket number, fare of the cabin. Okay. Embark means port of embark. C means Cherbourg, Queenstown, Southtown means there is a stoppage, guys, where exactly the, the ship is stopped. So this is the data set we have right now. I hope you understand, guys, all of these attributes. What exactly we are doing in this data set? From this data set, we are going to pre-process the data. It's a structured or unstructured. It's a structured or unstructured. It's unstructured because some of missing values are there and these tickets numbers are like this. I hope you understand, guys. Okay. What I'm saying, we are not going to build the model right now. We are just doing a pre-process the data. Understand how to do a pre-process the data? You know what is meant by, NumPy pandas, understand? And you do know that how to describe what describe will do. Explain name columns can never decide. Look at this, read these descriptions. Name columns can never decide whether the person is survived or not survived. So hence we can delete it. Did you see delete Titanic name? Understand, from the data, we delete this Titanic name and Titanic tickets as well. And one by one, can you do it today? Can you do it today, guys? Yasin, Abhishek, Avinav, everyone, guys. And post your output. So what exactly, yes, Chandrahash, what exactly you need to do? And what is the output from here? The output from here is, based on this data set, you can find out how many passengers are survived from the Titanic disaster. Understand? How many passengers are survived? So the end goal, did you see? From this is the final visualizations of the graph. So in this visualizations, who is survived more, guys? Male or female? Female survived female is 25 percentages. Not survived male 52 percentages. I hope you understand. Yes, guys. So this is called data pre-processing for beginners. I want everybody to, there is no for loop, nothing else, just basic codes, just understand and you can do it. Yes, guys, can we do it, everyone? Yes. So the two projects I mentioned here, the first one is data pre-processing. We understand how to import data set, how to import libraries, what is the pre-processing the data, train test split, all things we done. If yes, I will move ahead to another topic called, let's start regressions from today onwards. What exactly mean by regressions? If the dependent variable is continues in nature, yeah, continues in nature. Okay, so shall we discuss this one today? Yes, guys. So the voice is breaking sometime. No, is it for everyone? Online team? No. Okay. Let's see. Feature selections, I will tell you tomorrow. But let's heading towards one algorithm today. The first algorithms I'm going to cover up today is called simple linear regressions. What is this? Simple linear regressions, guys. Okay. Listen to me very carefully. Today onwards, I'm going to start algorithms, guys. See, and what exactly mean by simple linear regressions algorithms? We're going to understand all the concepts from the basic part, right? So this algorithm called simple linear regressions. This is the first algorithms in, where do I type it, man? Just one moment. Right, simple linear regressions algorithms. Listen to me. Simple linear means, what is the formula? What is the formula, guys? What is the equation? Y equals to mx plus c. How many dependent and how many independent variable? One dependent variable and one independent variable. Agree? Yes, one dependent and one independent variable. Now, in this data set, I'm explaining math concepts behind simple linear regressions algorithms. Yes, guys. Try to understand X and Y, which is independent, which is dependent. X is Independent, y is dependent. Agree? Now, look at these points I've been plotted here. Look at these points, means x-axis is 1, y-axis is 3. So x-axis is 1, y-axis is 3. Can I little bit up? That's okay. Understand, guys? X-axis is 2 and y-axis is 4. X-axis is 2 and y-axis is 4. Understand? Yes? Yes, Shekhar? X-axis is 3, y-axis is 2. Got it? Imran, understand? Yeah? If any questions, just let me know. Sadiq, all right? X-axis is 4 and y-axis is 4. Got it? Is this actual data or predicted data? Is this actual or predicted? Kirtan, actual or predicted? Actual, right? So x-axis is 5 and y-axis is 5. Got it, guys? Now, how many variables I'm using? Only two variable. Only two variable. Now, can I say the equations mean? What is the mean? 3 and mean of y equals to 3.6. So if I plot here, can I plot the mean here? 3 and 3.6, agree? Now, when I plot the point and when I draw this line, I get 3, 3.6. This is my point. Clear, guys? Understand till this point? Now go to the next step. In the next step, how to calculate slope m. To compute the slope, summation of x minus x bar, y minus y bar divided by x minus x bar whole square. Yeah. So, correct. So in this case, let's do this. 1 minus 3. Let's compute x minus x bar. 1 minus 3 is minus 2. Agree? 2 minus 3 minus 1, 3 minus 3, 0, 4 minus 3, 1, and 5 minus 3, 2. This part is done. Now go to the next step. Y minus y bar. 3 minus 3.6 minus 0.6. 4 minus 3.6, 0.4. 2 minus 3.6 minus 1.6. And 4 minus 3.6, 0.4. And here goes on. Done. So guys, what we are learning in machine learning, we type the equations like from sklearn dot linear model import linear regressions. Understand? So here we're not going to use any equations, but the background, whatever I'm explaining, this is what this equation is called from the background. I hope you understand, right? So I hope you're clear, guys, this one. Now let's do this. Go to the next step. X minus x bar whole square, minus 2 whole square, 4, minus 1 whole square, 1, 0, 0, 1, 1, 2, 4. Got it now? Yes. Now let me calculate this 4 by 10. So 4 by 10 means what, guys? 0.4. Guys, I hope you understand. So we know y, we know x, we know m. Don't you calculate c? Don't you calculate c, guys? So if I calculate c, I get c equal to 2.4. What is this c means? Intercept. This is the 2.4 intercept. Understand? Understand, Imran? Yeah. So this is 2.4. This is the intercept. Now this is actual. Okay. Now let's predict the future. How to predict the future? Let me tell you. Let's do this. Let me explain you again. Remember, let me open 2 times the slides. Just minimize. And I'll do it again. So this part. Correct. Just one moment. Right. So here we go. Mean squared error. What is meant by mean squared error? What is meant by mean squared error? Pratyush, C is intercept. M is coefficient. Understand that. Okay, Pratyush? C is not a coefficient. What is mean squared error? X minus X bar. Actual minus predicted is called mean squared error. I hope you understand. See, in this data, just one moment, something fishy. All right. See guys, remember independent variable 1, 2, 3, 4, 5. Okay. Now this could be my dependent variable. See this one. This is actual points or not? These points are actual or not, guys? Correct? These points are plotted based on this one. X is 1, Y is 3. Actual, correct? 2, 4, correct? 3, 2, isn't it? 4, 4, and 5, 5. Now, how do I make a future predictions? Let's do this. We know the y equal to mx plus c. Now, in this equations, we calculate m is 0.4, c is 2.4. We do understand how to calculate this one. Now, let me fit these values to my equations. Y equal to 0.4 into 1, 2.4, because x is 1, isn't it? X is 1 and my model predicted 2.8. So my dear friends, what exactly I'm saying, X is how much? 1 here, right? Y is how much? 3, isn't it? But Y had how much? 2.8. Guys, are you understand? Now the difference between 3 minus 2.8, do you see any highest loss? Do you see very high margin error? Less margin error, isn't it? So the same things, you understand this point. Now the second one, if I interpret this independent variable over here, 0.4 into 2 plus 2.4, 3.2. So X is 2, Y 4, Y hat is 3.2. So this is actual or predicted? Very good. This is actual or predicted, guys? This is all predicted. Online team, are you understanding? Predicted. Very good, Sunita. So let's do this the next scenario. Now, these lines is what? These lines what? Predictions point. This predictions point is created by model, simple linear regressions model. Now, when I connect all these points, oops, can I connect all these points? I'm sorry. This is called BFL, means best fit line. What exactly we call, guys? Best fit line. So don't you think so? This is best fit line, guys? Right? So did you see what is the error? The error is less on the first point. The error is little bit high on this error point. This is high. This is high. So if I build this model, now let me tell you guys, what is future predictions? Let me explain this one again. At this moment, I'm sorry. Let's minimize. I train the data till 1, 2, 3, 4, 5, right? Can you tell me if the independent variable 7, what exactly my model predicted? If the independent variable is 7, what is my model predicted? Can you compute and tell me, please? 5.2. Yes. So I mean 0.4 into 7 plus 2.4. So don't you think so, guys? You can predict the future petrol prices. Can you do it or not? Future petrol prices, can you predict or not, guys? Because the data I never trained before. I trained only historical data till 5 points. But I build the model, but these models is predict the future. I am going to create an app on upcoming next, after complete regressions and classifications. It's very interesting, guys. Those are the model is the backend and front end is app. And we do predict some of the good predictions in upcoming sessions. Clear, guys? This concept is all about simple linear regressions. Are you understand? Everybody's clear? Everybody's clear or not? What exactly mean by? So OLS, this part is called OLS, ordinarily squared or minimum squared error. This part is called OLS, mean squared error, distance between actual and predicted value. So what is R square and adjusted R squareds? So do you know the interview questions? Performance measures. See I'll send one question bank, means just 1 second, just 1 second. 10 a.m. and 6 p.m. Just one second. So this guy gave interview for Wipro company, I think day before yesterday. And these are questions asked by Wipro company. What is R square adjusted R squares? Can you tell me if I ask you these many questions, 13, how many of them you will answer? He's already get offers, guys, from Seal company. Now he got to get more package. He just shoot through these questions. I'm asking if you give interview right now, online team, how many answers you can give it to me? Let me copy. Maybe it's very small. Oops. I didn't copy this one. Copy, paste. What is R square adjusted R squares? Do you know or you don't know? You know, right? What is p value and its significance? You know this? How to check multi-collinearity? Did I explain? Yes. What is this multi-collinearity? Online team. Avinav, Yasin. If the attributes are not relevant, how to handle outlier in the data? Assumptions of linear regressions model. What is Z-score, T-score? Almost 10 questions, ROC, AUC. I'm not explained. Sensitivity, specificity, not done yet. Overfitting. Yes. How to overcome overfitting, guys? What are the issues we saw? Cross validations, regularizations, dropout, which type algorithms you used on your projects and how you overcome the problem faced during the project and to solve this type of problems, guys. Yes, this is real-time questions and some SQL queries like using join, group by, order, where clause, all these things. What is SVM parameters? So those things we didn't cover, just leave it. So minimum 5 you can answer or not, guys, by the time. Yes, minimum 5 or 6 you can answer. Anyway, I'll post this mentioned. Wipro. Do you want or don't want, guys? Wipro interview questions. My one student attends. So I just post it. So it would help you as well. Right. So now I already posted Sunita. Yes. Okay. The next one is, I hope simple linear regression is done. So let's do and build the model. Let's do and build the model. Okay, this is very easy steps and explain very simple way. All right, explain very simple way, guys. Let's go back to the work. Let me open this. In this data set, how many variables we can see? 2 variables, right? What is independent? What is dependent? What is independent? What is dependent? Rakshayani? Salary is dependent or independent? Independent. Dependent. So can I mention why? Can I mention why? Year of experiences X. So who will give M and C? Your M and C given by your simple linear model. Correct. You're not going to do any equations manually. So can we build this model, guys? How to do this? As I have the equations y equal to mx plus c, one dependent, one independent. That's why, I'm sorry, this is dependent, this is independent. This data set is fit for simple linear regressions, correct? Now let's minimize this. Let's minimize this and just one sec. So here we go. Now I just need to change my path locations over here and very simple. Control V, right? So let me restart my kernel. Done. So just one sec. All right. So very simple thing. Let me restart it. Okay. So here, NumPy, Matplotlib, Pandas. Can I say this? Yes. This is the first step. We import this. Oops. Okay, done. The next one, import the data set. You know how to import the data set, right? So no need to explain. Done. So the data set is ready. Is a clean data? Of course, it is a clean data. Yeah, this is the clean data. So salary of experience is independent variable. This is dependent variable. Yes, online team. And if I remove this one, this becomes my X. If I remove this become dependent Y. Correct. So close this. And finally, dataset.ilog. What exactly ilog will do? Remove it, split the data. Very simple. Do this. And y variable dataset.ilog, one value. Let me do this. So I have the data set over here, and I split my data into independent and dependent variable. Understand or not understand so far? Yes, team, clear? So I have one data set. I divided it into dependent and independent variable, right? Now let's close this. What is the next step? The next step, regressions does not require feature scaling, my dear students. So let me tell you. So here I could say regressions does not require feature scaling because the output variable is integer. Variable is integer. So in the dataset pre-processing, the dataset was classifications or not? Data pre-processing, right? A customer is purchased the item or not? Yes, team, everybody's understand? Shekhar, are you understand or not? Yes. So this one. Okay, Arshad. So let me, these points, whatever I mentioning, this is key points, guys. So please do not destroy these points forever. I'm just saying one thing. All right. So the regressions does not require feature scaling because the output variable is integer. Classifications we must require. Okay. Now let's do this. Let's go back to the practical. And here we go. So that's why train test split. Directly I implement with the splitting part. Train test split. If I take 20 percentages, how many records is splitting part, guys? Out of 30, 20% means 6, 4. Just do this. 6 and 24. See this, guys? Total data set, I have 30 rows, 2 columns. Understand? And after that, I split into independent 30 rows, 1 column. Clear? Dependent 30 rows and 1 column again. Xtrain, Xtest, 30 has split into 24 rows and 1 columns. Okay. And Xtest has 6 rows and 1 column. Yes, guys. Now let's do this. Data set, independent variable, dependent variable, Xtrain, Xtest, Ytrain, Ytest. Got it? Yes. So Ytrain, Ytest, and Xtest, Xtrain, X variable, and Y variable. Team, everybody's clear or not clear? Yes. How the data has splitted. Have you done anything? You didn't done anything. It's everything is done by your packages, scikit-learn packages. That's why we called scikit-learn is the machine learning frameworks. Understand? sklearn is the machine learning frameworks. Whenever you build resume, you must mention sklearn. Understand? Yes, team. Whenever you mention resume, you must mention scikit-learn. So let's close everything. The next step would be right. So linear regressions. Okay. First understand linear regressions. I'll talk when I keep my cursors. Did you see? I didn't click. I keep my cursors over the model algorithms and the help options is popped out. Just go back to this one. Let's understand. Are you guys getting like this type of help options in your environment? You fix the issue? You sort it out? Yeah, very good. It's take entire day, right? I know these things, it happen. So just 1 second. So here, let me tell you, if you do not find this type of help options team, so what you need to do, just go back to here and mention and find out sklearn. What is that? Simple linear regressions documentations. Understand? sklearn simple linear regressions documentations. Just click over here. Step 1, step 2, all those things is given, but we want this one. The logo of the scikit-learn is this, guys. The logo of the scikit-learn is sklearn. Did you see sklearn dot linear model dot linear regressions? Okay, fit intercept true, normalized depreciated copy x true, and jobs done. So when I mention linear regressions, listen to me, guys, what exactly I'm saying. When I mention linear regressions, in the background, this functionality is understanding whatever explained today. This equations has call in the backend, understand? And you don't need to compute all these formulas, guys. Okay, so it will understand automatically and build the model and fit the model, guys. Understand? So you no need to do any parameter and hyperparameter tuning. In real time, are we going to use this? My question, a big no. Simple linear regressions we never used in real time because in the database contains many attributes, right? Isn't it, guys? In the organization's database, we have more columns. So you cannot build the model with 2 attributes. But still, why we learn? We need to learn for a comparison for clear the interviews. Did you see ordinary least square linear regressions? Linear regressions fits a linear model with coefficients W, okay, to minimize the residual sum of square between observed and actual. Team, are you understanding? Are you understanding what exactly I'm saying? It's clearly mentioned over here. And what is this parameters? Did you see fit intercept bool default equals to 2? What is bool? True and false, right? So you can check what happens if you change from true to false. Normalize bool default false. Yeah, this parameter is ignored when fit intercept is false. So L1, L2, I didn't cover. No problem. I'll talk to you later. All those things, guys. Yeah. So at this moment, there's not much things to do. So let me build directly. No hyperparameter tuning is required because there is no big concepts. Very simple. One equations we have over here. Now, understand up to this, guys. Very simple. Let me build this one linear regressions from a sklearn.linear model. Import linear regressions. I build. Now, to store this linear algorithm, we need to create an identifier, right? So for that, I created a regressor. So let's execute this one. And I will fit this regressors.fit, train the model, isn't it? How to build a model? We need to train the model. So train means what? X train and Y train. So let's build the model X train and Y train. Guys, are you understand? See this? The model is getting ready. Yes, Yasin. Finally, YPRED, I create a predictions identifier. Regressors hold linear regression algorithm. Understand? Yes, this regressors hold dot predict X test. I pass, I train with train, and I pass X test to predict. Let me tell you, to predict YPRED is generated. So what I told you, I am going to create a actual versus predicted. We compare, right? So Y test is actual or predicted? Y test is actual or predicted? Actual or predicted Y test? Actual? Actual. Y test is actual. X train, X test, Y train, Y test. Those are actual, right? So this is YPRED is predicted. See this. Now Y test and we compare with YPRED. Actually, the patient's, the employee's salary is 37,000, right? My model predicted 40,000. Accuracy is there or not? Good accuracy or bad accuracy? It's okay, we can manage, right? Actual 122 by model predicted 122. Guys, are you understanding or not? Actually 57,000 my model predicted. Now, how do I visualize? If I plot the line, let's see how exactly I create a graph. In this case, I wanted to make a scatter plot, X train, Y train, color red. Okay. I hope you understand plt.plot X train regressors.predict color blue, X level year of experience, Y level salary, and then show. Let's do this. Copy image and paint. What is the total data points? What is the total data points, guys? 30. 30. So salary versus experience training data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 20, right? But now, see, plot the difference between training part. What is X test? If I make this to X test, okay, let's do this. Copy image and let's build this. 80-20% means out of 30 records, 24 is train and 6 is test. 1, 2, 3, 4, 5, 6. Understand? Yes. So this is actual point. The blue color is model predicted. So is it a good model or bad model, guys? How come you say that? Did you see almost 5 data points are almost closest to the predictions point? Did you see any outlier? No, I don't find any outlier, guys. Team, are you understanding or not? Are you understanding or not, guys? Everyone, online team? Okay, very simple. See, sir, please explain this plot. Very simple. I'll share this today. Plot.scatter X test, Y test. Let me tell you guys, very simple. X test, Y test, color red. I done this. PLT plot X train regressors dot predict X train means predictions. This is called predictions. I need to make the color blue. Okay, this is what regressions dot predict X test. This is called Y pred. All right. And then title, salary experience, X level, Y level show. Very simple code. Don't say, sir, you'd explain very fast. I hope you understand, online team. This is very simple code. Still, if you think I'm very fast, then I'm sorry, guys. I'm explaining very slow again. I'm saying clear. Simple data set. Congratulations, guys. The first model we built today. Okay. From here onwards, I'm going to give you a lot of work and a lot of practical as well. Now, you may ask one question. Okay. In the data set, I have how many variables? 2 variables. Okay. Now, if I give you 50 variables, another questions, this is what another interview, technical questions, the technical questions. Can I plot, can I build simple linear regressions model from 30 attributes? Yes or not? Yes or not, guys? Then if I build 30 attributes, but as we know, one dependent and one independent, right? How do you say yes, guys? Wait, how do you say yes or no, guys? Multiple linear. Okay, Arshad said multiple linear. So Arshad, you don't think so that we can build one attributes? Okay, now I'll give another work for you. Just 1 second. Very interesting works, guys. If you complete, you gain a confidence, to be honest, I'm saying. Simple linear regressions and link.txt. Correct. So let's open this one. Okay, now I'll show one notebook. In this one, just understand, predict housing prices. Okay, predicting housing prices using simple linear regressions. All right, now let's go back to the data and let me download this data. Let me download this data first. Okay, yeah, I hope it's done. So let me go back to the download parts and let's extract to this one. All right, just 1 second, guys. All right, so first I will discuss tomorrow this one. In the meantime, you can work these 3 things, guys. I am share you all those details, right? So here May month 12th, and did I send this one, data pre-processing? Not yet, right? So I will send this one as well. See, I can complete, but I want you to please work and let me know, guys. Update your status on Classroom. Okay. Yes, online team. Are you understand or not this part? So can I give this one? Let me post. Just 1 second. Okay, I'll share this one as well. Tomorrow we're going to start multiple linear regressions. Before, I wanted to make feature selection is pending. I'll speak about it tomorrow. Okay. So simply, please work with these 3 tasks today, and tomorrow I'll give you another simple linear regressions. All right. Yes, yes, team. Okay. And just give me moments. I'm gonna send right now, or else I'll be busy with some other work. It's done, and you need this one as well, right? Project list also. Regressions are okay. They're mentioned over here, right? So this one also we need project 16. We called simple linear regressions. Please complete these 3 today and let me know if you have any issues. Okay, and update your works on Classroom. Clear? Let's done this. Let's done this and done. Yasin, Avinav, everybody's clear. Sunita, offline team. Yes, guys. Please do it and update me. 1 sec. 10 a.m. And here we go. Browse. Desktop. Okay, see you tomorrow, guys. See you tomorrow. So the code notebook shared. Yes, I shared. Arshad, you have issue. Sumit, can you please guide him how you done this from downgrade to 5.3 to 4? In Mac, Arshad, you need to spend some time because I don't get time. I'll get back to you anyway. Okay. Yes, Arshad, I'll get back to you about this one. Okay, just in the meantime. Oh. Done, I sent. Okay, I'll explain tomorrow. I'll send. In the meantime, you have 3 files. Please work on it and update me the results. Okay, team. Yes, Washim. Okay. Arshad, in the meantime, please work on your Jupyter or else. Okay. Yep. Shared. Everything is shared. Please complete these projects and update me today. Best regards. Thank you, guys. See you tomorrow. Okay. Bye, guys. Thank you. Everybody, online team, please, everybody need to complete today. All right. And then get back to me. All of them. Okay. Thanks. So class notes project list 12th. Do it. You working? Yeah. Thanks. Bye. Okay. Done, guys. Have a good day. Some new batches started, seems, so I need to be logged out soon. Okay, thanks. Okay, yeah. Bye, guys.